All right, simplifying radicals, we want to determine if the number under the radical is divisible by one of our perfect squares. And you see over here on the right, I have our perfect squares, and we call these numbers perfect squares because if you take the square root of these numbers, you get a whole number as a result. And so I wouldn't test your number under the radical to see if it's divisible by anything that's more than half. So I wouldn't want to test 50 to see if it's divisible by anything more than 25. And we should quickly recognize that 50 is 25 times 2. And so that can be written as the radical 25 times radical 2. And the square root or radical of 25 is 5. So 5 radical 2. Now, you always want to choose the largest common or perfect square divisor. So with 32, it first may come to mind that 4 times 8 is 32, which is correct. And that would give us the square root of 4 and the square root of 8. And the square root of 4 is 2. So we get 2 radical 8. The only problem is 4 also goes in 8. So you'd have to take this step, process one step further. And 8 is 4 times 2. And so we get 2 radical 4 radical 2, which is 2 times radical 2. So 4 radical 2. We could have saved ourselves some work by using 16 because 16 also goes into 32 and it's the largest of the two divisors. So if we had done 16 times 2, we would have ended up with square root of 16 times square root of 2, which is 4 radical 2. All right, on to our next two examples. You notice that the number under the radical is negative. The least you can do in any of these examples where you have a negative under the radical is pull the negative out by putting an I out front. Now, what this looks like with the work like I've done on the past two problems is a square root of, or radical of -1 times 17. And we need to remember with imaginary numbers that the square root of -1 equals I. And so if we have the square root of -1 and the square root of 17, the square root of -1 is I, so I radical 17. Now that is the least that you can do in any of these problems. 17 is not divisible by any of the perfect squares that we have listed on the right. And so this is the final answer. That's as low as it can be solved or simplified. Our third example, our fourth example over here on the right, 20, we ought to know that it's divisible by 4. And so if we take the square root of -1 times 4 times 5, then we can break this down to square root of -1, the square root of 4, and square root of 5. The square root of -1 being I, the square root of 4 being 2, and then the square root of 5 doesn't get reduced, and so, or can't come out of the radical, and so our final answer is 2 I radical 5. Now I also want to look at some problems with I. And so with imaginary numbers, the important things for us to remember is that the square root of -1 equals I. But what is also true is if you squared both of these to get rid of the radical, you get -1 equals I squared. And so that's very important as we look at these problems here. My suggestion is to always write your i's as I squareds. And so I to the fourth would be I squared times I squared. And so essentially -1 times -1, which is a +1. Now, a rule of thumb that would come from doing a lot of these problems is that if the exponent, if you have I to the even exponent, your answer is going to be 1 or -1. And if you have I to the odd to begin with, your answer will be I or -I. So right off the bat with I to the fourth, I knew the answer would be 1 or -1. I just had to work it out the rest of the way to figure out if it was 1 or -1. Now, with I to the fifth, we can write this as I to the fourth times I. Now, another way of writing I to the fourth, besides the way I wrote it in the first problem, would be I squared squared. Okay? And I squared squared, well, I squared is -1, so -1 squared times I, -1 squared is 1, so we have 1 times I, which gives us an answer of 1. I'm sorry, I to the 30. I know from the get-go it's going to be 1 or -1. And what that's really going to come down to is this is I squared to the 15. Well, I squared being -1, we're going to take it to the 15th power. Well, a negative number multiplied by itself an odd number of times is always going to stay negative. So this answer will stay -1. Now, 45, we're going to take 1 off of it and have 44, I to the 44 times I. That's why the answer is going to be I or -I in the end. It's all dependent on I to the 44. Well, I to the 44 is I squared to the 22, and the 22 comes from 22 divided by, or 44 divided by 2. And since 22 is positive, or even, when I take I squared, which is -1, an even number of times, we're going to get a positive 1. So 1 times I equals a positive I. All right. So just another little note over here that if we have I to an even, or let's say this, if we have I squared to an even, we know that it's positive 1. And if you have I squared to an odd, you know it's -1. And so that's another little thing. Once you break it down, you can use those notes right there to help you get your 1 or your -1. Now, we also have some problems here with multiplication, just some general simplification problems using this idea of I squared. So 3i times 5i is 15i squared. And because I squared is -1, this is 15 times -1, which gives us a -15. In our second example, I would suggest, well, first of all, you have to square the 2i. So that gives us 4i squared times 6i. My suggestion is that you go ahead and simplify your I squared to -1. So we have 4 times -1 times 6i. So that gives us -4 times 6i, which gives us a -24i. And that will be the simplest way to simplify that. On this next problem, we have an I squared inside the parentheses. And again, I would probably go ahead and simplify that. And so that gives us -4 times -1 inside our parentheses, which gives us 4 squared, which gives us 16. And so that would be our final answer. If you wanted to go a little further, or if you didn't simplify that in the beginning, you would end up with 16i to the 4th, which again, we can simplify the I to the 4th, which gives us 16 times I squared squared. So 16 and the I squared being -1, and gives us 16 to the -1 squared. -1 squared is 1. So again, we're still with an answer of 16 either way.